Android Studio has a number of monitors that you can use to keep track of memory, CPU usage, and other resources on your device as you're running your application. I'll demonstrate some of these monitors using an existing Android Studio project that I've included in the exercise files. I'll go to my exercise files folder, to the Chapter 6 folder, and I'll open the project Memory Eater. After opening the project, I'll do a clean on it to make sure it's updated for this version of Android Studio. When you open the project in your copy of Android Studio, you might be prompted to upgrade your Gradle plugin version. That's because I built this project using a beta version of Android Studio and the Gradle plugin. And you can see this in my copy of the build.gradle script on line 8. This setting must match your copy, which will probably be more recent than mine. I'll run this app on my virtual device. Now, for this demonstration, I've positioned the virtual device so that I can see both the device and Android Studio. Now, if you see this happen, that Memory Eater has stopped, just click OK on the device, come on back to Android Studio, and build the project again. And then the next time you run it, it should run just fine. Here's what the application does. There are two buttons labeled Eat Memory and Release Memory. When I click the Eat Memory button, I'm running an async task, and that task is adding items to an array list. It's going to add 200,000 items, consuming more and more memory. It'll max out at 200,000, but as I'll show you in a moment in the actual code, this is very easy to adjust if you want to do other tests. After the process is done, you can then release the memory by clicking this button. Now let's take a look at the code. I'll press the Shift key twice and type main act, and then select my main activity class. The main activity class has two fields, referencing a text view and a list of strings. The list of strings is instantiated in the onCreate method. Then there's an eat memory method that's being called when you click that button, that's creating an instance of an async task object and executing it. The async task class has an onProgressUpdate method that's being used to update that text view. Then there's a method called release memory that's clearing the items from the list. So now, let's see what happens when we run the application and watch the memory monitor. The monitors are here in the Android Monitor window on the Monitors tab. After opening that window, I'll double-click the bar at the top, and that will let me see all of the monitors for memory, CPU, network, and GPU. Then I'll go back to my device, I'll exit the application, then I'll look at my list of recent applications, and I'll remove the application from memory, and that disables the monitors in the background. Now I'll come back to Android Studio, and I'll run the application again. When the application first starts up, you can see that it's consuming a little bit of memory. Now the exact numbers will differ from one system to another, but there are certain patterns that should be pretty much the same. I'll click the Eat Memory button, and I start consuming memory. Interestingly, initially the memory usage goes down, but then as I consume more and more memory, adding more and more items to the list, the memory starts jumping, and the amount of memory that's allocated isn't allocated in a linear fashion, but in chunks. You can see how much is free and how much is allocated. Then, once I'm done adding items to the list, the memory usage flattens out as you would expect. Now here's an interesting thing. When I click Release Memory, nothing really happens. You see a little bit of a jump actually right there. But then I'll come back to Android Studio, and I'll click this button here labeled Initiate GC for a garbage collector, and immediately the memory usage drops. So that's an example of how you can use the memory monitor to find out what's going on internally on your device. You can also see some jumps in CPU at times. For example, when I cleared my list, there was a little jump in CPU message right there. The memory, CPU, network, and GPU monitors are incredibly useful for finding out what's going on the hardware as you run your applications.